Okay, so today's lesson was running non-linear regressions. If you go to third period and go to your modules, December 14th, and download this Word document. The data sets are there. However, after the lesson today, I realized, I could have just added a new tab to the Google spreadsheet, and then I could have just put all the data there. So I did that. I will send that Google Sheets to you, and then you won't even need this Word document. The Word document does contain the context. It tells you what the variables are. Maybe if I forget, I'll look back at this document. But so let me find the template. Here's the template I'm going to send you. Along the bottom row, it shows a tab for linear regression, exponential, quadratic, power, logarithmic, and then I added this new tab right here that has all the data sets in it. We did this first problem together, and then you had, I think there were 6 problems total, so you needed to do 5 more on your own. The reality is, once you get good at it, each problem probably only takes maybe 5 minutes at the most to do. At the most. So that's 25 minutes worth. Now, some of you were having some issues in class today with Wi-Fi. Some of you were having just random issues, like, don't want to get into it, but so here's what you're going to do. You're going to copy this. I don't even remember what this data is. I'm going to go to the Word document. Let me check it out. So that very first problem is dealing with U.S. exports to Colombia. So in 1990, that was the first year recorded. The data was recorded. The United States exported $119 million of goods to Colombia. What type of model, regression model, fits this data is what we're going to figure out. And I already have the data here, but I'll erase that. The reason why scientists, business people, government people would even want to collect this data is so they can make predictions for the future, to plan, basically. Or maybe they're just curious. Sorry. Trying to find the document again. There it is. That's what this data is. So X is the year since 1990. Y is the amount exported to Colombia in millions of dollars. Anyways, copy this, Control C, bam, and go to the linear regression page. I already have it there. And delete that. So there should be some data there. Delete it, paste in the new data. Control V is how you paste in the new data. Bam. And right here it tells you R squared equals 0.963. So you have to actually come here and manually input that. 0.963. Once you press enter, it will automatically take the square root of that number for you and tell you the R value is 0.981. And then you do that for each of the functions. Like I said, when you get, it's really just copy and pasting the same data set. So once you get real good at that, it might only take you a few seconds to do it. So bam, bam, it tells you the R value I already have the R squared values plugged in here, so let me go erase everything real quick. Delete. I'm going to pretend like there was no data here to begin with. Okay. Logarithmic, bam, bam, bam. Delete. And I think we're good. Okay, so the issue with exponential regression with Google Spreadsheet is it spits out this equation that we have never really experienced. So I had to input a new formula so it gave it to us in the form that we're familiar with, which is a times b to the power of x. Don't know. So there's your a value right there, 122.8, and the b value is 1.122 to the power of x. And as you can see from the graph, it's actually a very good fit, meaning most of the data points are very close to the curve. Is it the best one? I don't know. The way you can tell is by looking at the R value. The one with the R value closest to 1 or negative 1 if the data is going down is the best model. And also keep in mind, this is like intro to stats, so you're just learning 5 very basic models. There are a lot more than just 5. Let me go back to quadratic. So you have to take this R squared value, 0.988, and you have to manually input it right there, 0.988. As soon as you press enter, it will square root that for you, and you get 0.994. Then you go to power, Control V. If you have trouble with copying, pasting, Liz is definitely the person you want to go to. She's the expert at copying and pasting. And if you need to make a copy of the file, Travis is definitely the one to go for that. Okay, R squared is 0.944. Put that right there, 0.944. Enter. Logarithmic. Click on that first cell, Control V, and as you can see, it's a pretty good fit for these far right data points, but this one over here, it's not even close. So right away that tells me that logarithmic is probably not going to be the best model. Oops, enter. If it wasn't for that point, this point right here, then it looks like logarithmic would be the best model. But so anyways, we got 0.959, 0.971, actually 0.972, 0.994, 0.991. So exponential and quadratic were super close, almost a tie. And linear, 0.981. Take all that, go to the Word document, write down those answers, and like I said before, the one with the highest R value is the best model. So quadratic just by a little bit. And then you can also, from the quadratic model tab, right here it tells you the equation. It is backwards. That's C, that's B, that's A. I don't know why it does it backwards like that. Other than, I don't know why. Can't even begin to guess why it tells it to you backwards. Anyways, transfer this equation back onto the Word document right here so that you can answer the question. The question is, predict U.S. exports to Colombia in the year 2030. Because the year 2030 is not in the table, that's called extrapolation. It's outside of the data. Like extraterrestrial means not on Earth, outside of the Earth. So anyways, if 1990 is year 0, then 2030 would be year 40. It would be the 40th year. So you just replace the X's with the 40, and you end up getting $2,940 million exported to Colombia in the year 2030. If you wanted to see how accurate this model is at predicting, the nice thing is you could use 2000 as our sorry, I was doing math in my head real quick. You could use the year 2000 and then just do real quick research. I bet you it's on Google somewhere how much we actually exported to Colombia. So, and the thing with prediction models, you've heard me say this before, they are not 100% accurate. Never will be. They're just predictions, and they're very accurate, though. Very accurate. Generally speaking. Problem number 2. Planets of the solar system. This is how long it takes them to revolve around the sun. That's called the period. Ooh, that's when you're going to learn more about period in the next unit, actually. And this is the radius of the orbit. This is X, actually. This is Y. The data in the table is backwards. I don't know why, but I fixed it for you. So we're going to figure out which model is better. Come here. So first thing I'm going to do is clear out all this old data. Delete. Like I said, when you get to college and you have to take a science class or a math class or any kind of class that requires you to do research and collecting of data and analyzing of that data, you're going to thank me later for this document. Remember, it's saved forever on your Google Drive. Notice it does not delete this. I think I know how to do it now, though, but okay, so data set number 2 is the Control C. That's a Liz special right there. Come here, Control V. Look how close these points are to the line. That means linear is a good model. Is it the best model? Don't know. I have no idea. Ooh, that's pretty high. Exponential. Control V. Not as high. Not as high. 0.954. 0.954. And I entered it wrong. 0.954. Okay. Pretty close though. So both linear and exponential would be good models. For sure. Best model? Don't know. Bam. And r squared equals 1. Square root of 1 is 1. So apparently quadratic is perfect. Oh, that makes sense. If you think about the orbit of a planet, the shape of a quadratic function is parabolic, right? If you put two parabolas together, you get the orbit of a planet. Makes perfect sense if you think about it. So we already have the winner. I don't know why I'm even doing this anymore. Oh. Why? So power function also gives us an r squared of 1. Interesting. Very interesting. I wonder if it's the computer is rounding. Let's look. If you look at the data points, the curve seems to be going through exactly in the middle. Let me check quadratic real quick. Yeah, I can already tell. Look at that. See how it's not going through the middle of that one or the middle of this one? So this r squared equals 1 is rounded. It's probably like 0.99 something. So power is actually the winner here. Barely, but it is the winner. But we're going to use quadratic because I like my two parabolas make a elliptical orbit. Hypothesis. Okay, 0.6 logarithmic function is not even close. Not even close. So the winner here is quadratic, or you could say power, I guess. And then the question here, so you want to record all those R values because you need to have evidence. If you say quadratic is the best model but you don't have evidence to support your claim, it's like it doesn't even count. Like an opinion with nothing to back up that opinion. So if planet 9, aka Nibiru, aka planet X, has an orbit of 420 million kilometers, meaning if son of a dookie, I meant insert row below. Insert row below. Okay, so if I were to put a 420 here, what would this number be? Well, obviously it would have to be somewhere between 1.88 and 11.86. So, doesn't matter which regression model we use, quadratic or power, either model should give us a good answer. I'm going to go with the quadratic one. So we need to take this. I wish there was a way to copy and paste this equation, but so my suggestion is write it down on a piece of paper. Negative 1.56 plus 0.0154x plus 4.79e negative 06x squared. If you were in class today, I tried to explain what the meaning of e is. It's just engineering notation. So basically all that means is move that decimal point 6 places to the left. Left because it's negative. Okay, so basically it's a very, very small number, which is why the curve, it's not a dramatic curve, it's a very slow curve. Okay. I'm beat. I don't know about you guys. I'm beat. Negative 1.56. I'm actually going to write the equation backwards. You know why? Because I don't care. 0.0154 plus 0. I might let you in on a little scientific notation secret. The exponent was negative 6, so I needed a total of 6 zeros. There's 1, 2, 3, 4, 5, 6. X squared. There's the equation, and then we just got to replace the x's with 420. I could show you guys how to do the hat, but I don't really care. You can spell it y hat. Y hat. Why hot? Why so hot? Why so serious? 0.56 plus 0.0154 plus 0. Oh, you guys see what I forgot to do already, right? I forgot to replace. Well, first of all, I forgot the x right there. It is quadratic. Remember, quadratic is ax squared plus bx plus c. And you plug this into some calculator. Travis, I think Travis used Google or Miko. Travis or Miko, I can't remember. Just plugged it into Google. I didn't know you could do that. So I'm going to copy and paste. I like to call this the Liz special. Control C. I'm going to go to Google and see if Google can do this for me. Wow, it did it for me. 5.75. 5.75. I can't believe it did it for me. Did it do it correctly though? I don't know. I don't have my graphing calculator, so it seems reasonable. If we go back to this document, it does seem reasonable to put a 5.75 there. Yeah. It's a reasonable answer, so I'm going with it. 5.75. That's not what we got in class, Travis. At least I don't think that's what we got in class. If we use the power regression model, I'm sure our answer would be similar. Okay, one more example. Let's do one more. Then you have to do all this by yourself, on your own. Alright, first things first, let me clear out all this old data. Delete. 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 And delete. What problem shall we do next? Data set 3. I think this is about road runners. Some poor scientist has to collect data on road runners. Can you imagine what that dude or girl did to get in that much trouble that their boss said, hey, you see those road runners over there? Go measure their speed or count how many there are. Shoot, you know you got in trouble when that happens. Okay, so I don't want to do data set 3 because that's boring. What's data set 5? What's data set 5? Oh, that's about the tree growth problem. So year 1, the tree was 6 feet tall. Year 2, 9.5 feet tall. Year 3, 13 feet tall. So this one was interesting because it turned out that when we ran the regressions, quadratic was the best one. But we all know quadratic goes up and then down, and trees don't grow like that. So I don't remember which function had the second best R value. I think it was power regression. No, it was logarithmic functions. Do not curve back down. They just go up and they slowly go up. So when we use the quadratic regression model, we ended up eventually having a negative height for that tree after 50 years. And we know that's not possible. That's not logical. But if you use the logarithmic regression model, you get an answer that's reasonable. I don't remember how tall it was after 50 years. I think it was like 30 feet, something like that. So, sometimes you can do all this math and still have to use your brain. Okay, let's do, there's one more data set. Yeah, this one is about crime. So in 1971, there were this is actual FBI data, by the way. There were 300,023, my daughter just learned how to say this number in 3rd grade. 323,060 violent crimes in America. And of course this number should go up. You know why it's going up? Because the population is going up. So the reality is we need a 3rd column right here that shows percent of population. And it should be pretty similar the whole way down. And if there's spikes, then you, as a data scientist, you would go, why was there a spike? This is why I love math and history and science, because it's all connected. Look at this. Going up, going up, going up. There was a spike in 1982. Why? Why was this weird spike? I'll let you in on a little hint. In the late 70s, there's something called an energy crisis. Caused a lot of people to be poor. You know what happened to poor people? They get violent. It's human nature. Then numbers dropped. 80s were pretty good times until the late 80s, and there's a spike again. What the heck is this? Look at that giant spike right there. Guess what happened to the late 80s? Gang violence went out of control. Why did gang violence go out of control? Same reason why right here. When times are tough, people turn to crime. That's just human nature. Okay, and the data ends. 1997 was the last year that data was collected. Obviously, more exists. It's just I got tired of writing writing data. Alright, let's do this one. Let's find, I'm going to guess is linear. If I had to guess, I'd guess linear would be the best regression model. About to find out. Bam. Yeah, look at all that. Look how close the data points are. It has a pretty high R value, 0.922. My prediction, without even having done this problem, is that this is going to be the winner. Exponential. Is that literally the same number? What the? That's not the same number. Let me check. 0.922. What? How is that even possible? Mind is blown right now. Okay. Oh, well. Apparently quadratic's even a little bit better. Was not expecting that. Power regression. Oh, dang. We have a new leader. Okay, power. Logarithmic. Here we go. And what the? How that? I don't even know what to say. I've never seen a problem like this before, where 3 out of the 5 had the same R squared value. R squared is coefficient of determination. You got to know that for the test, the vocabulary. But you all wrote down the vocabulary on the Google Doc somewhere, so ain't no excuse for missing that type of question. So, what you guys gonna? What was the winner? Power. 0.966. 962, 960, 960, 966. Power regression wins, but just barely. Oh my gosh. Here's the thing though. Look at the equation. It's 1.33 e to the negative 202nd power. Guess what? I'm going to go with linear. All the R values are close enough that any of the models will give you an accurate prediction. So I'm going to go with the easiest of all the models. What the? Look at that. Okay. Nope. I'm trying to find one with no E's in it. Nope. Quadratic? Quadratic. Bro. Exponential? Bro. Well, yeah. So this is a positive exponent, so we need to move that decimal point 7 spaces to the right. 7 spaces to the right. I'm going to write this down. You should write it down to 17357x plus negative 3.39 e plus 0.7 really means times 10 to the power of 7. And I'll let you guys in on a little secret. If I can find a calculator that works. Let's try Google Calculator again. So we have, how do you clear this? There we go. It is negative 3.39 times 10 to the power of 7. This number, 10 to the power of 7, is going to be extremely low. Extremely negative, basically. Look at that. Jeez. So yeah, you can plug in, as long as you know that E 7 means times 10 to the 7th power, then there you go. 33. I'm gonna, just for estimation purpose, I'm gonna write negative 34 million when I write the equation. Okay. At this point, I don't even remember the negative 34 million and plus 17,357x. Okay. And then it asks how many violent crimes were there in 2019. So in 2019, that would be, remember the start year is 1971. In the year 2019, that would be, let's see, 29 years plus another 19. 29 plus 19 is 38. So the x would be 38. I'm actually a little bit nervous that this is not going to give us anywhere near an accurate result because I went with linear as the regression model. And who knows if it curves up massively at some point in the 80s. Control C. Google. Yeah, that answer clearly makes no sense. So, let me go back to linear regression model. Make sure I wrote the numbers down correctly. Negative 3.39E7, 17,357. Nope, I did that correctly. Okay, so no bueno. I'm trying to find the next easiest one to type, and that is not it. Oh my goodness. Definitely not that one. Shoot. Quadratic. I'm going to go with exponential. It's that e negative 22. E negative 22. Oh, here we go. Oh, yes, look at that. Nope. That's not going to work. Dang. You guys see how it says 0 here? But if you look up here, it actually tells you what the number is in reality. It's such a small number that the computer doesn't want to write all those numbers. It just writes 0 instead. Yeah? Weird, huh? So I'm going to go with this. But instead of 0, or instead of this extremely small number here, watch what I do for my prediction model. Oh my gosh, 37 places to the left. Are you kidding me? There it is. Okay, so linear definitely didn't give us a result that meant anything, so I'm going to go with exponential instead. The A value was a ridiculously small number. Watch what I do for my ridiculously small number. Good enough, yeah? And then the B value was 1 point something, that's all I remember. 1.051. I'm going to go with 1.051. To the power of x. So I'm going to use this as my regression model instead because linear did not give us an answer that made any sense. Let's try this one. 0.001 times 1.051 to the power of 38. Let's see what happens here. Yeah? Control Z. I have a bad feeling. I have a bad feeling. It's like Star Wars. I have a bad feeling about this. What the? There's that E again. So that one didn't work either. Let's try a not so small A value. That is still, you can't have 0.066 violent crimes. Try this. Nope. Let me try 1. Nope. 6.62. I'm missing something. Like, why are we getting such bizarre answers? Okay. Like I said, I wish we could just copy and paste this equation, but we can't. I'll figure it out. I'll figure it out. It's always got to be a way. Always has to be a way. Alright, quadratic. Okay, linear didn't work. Exponential didn't work. I tried to even cheat the numbers. Didn't work. Let's try quadratic. 5.96 E08 positive 08 plus negative 617244x plus 160x squared. Okay. I'm just going to go straight back to here and try it here. 5.96 times 10 to the power of 8 plus negative 3.39. Nope, my bad. Looking at the wrong number. Plus negative 61724. X is 38 plus 160. I'm crossing my fingers that this one gives us a reasonable answer. I don't even remember what the question is at this point. How many violent crimes were committed in 2019? I would guess like 1 point something million. That is too much. Comma. 572 million violent crimes. That means every person in the United States got assaulted more than one time each. That didn't work either. Mother dookie. Did I write it correctly? Yes. Yes. Ugh. Strike 3. I'm gonna end this video. Try to figure out what's going on, and I'll make an addendum video. Yeah. I will find out what's going on, though. I may not find out how to stop this video. Bam. 8.